All right, you guys, so I think I found a new way to record stuff for you, so we'll see how this goes. You guys can give me some feedback on how this goes, but I want to do a couple extra practice problems for determining the quantum numbers for an element. So I'm going to do 4 here. I'm going to start with an easy one. So I'm going to start with nitrogen, which is number 7 on the periodic table. So I need to get the electron configuration first. So the electron configuration for nitrogen is 1s2, 2s2, and then 2p3. Okay, so I'm really focused on this last orbital. So I've got a p orbital, and it has 3 electrons in it. So I've got 3 up arrows. Remember, you have to put 1 in each one before you go back and pair them up. So I've got to try to figure out what the 4 quantum numbers are. So I'm looking at what is N, what is L, what is ML, and what is MS. So if I take a look at this, again, N is always what level is it in. So this is in level 2. So my N is equal to 2. Now remember, my L is what orbital is it in. So an S is always equal to 0, a P is always equal to 1, a D is equal to 2, and an F is equal to 3. So this is in a P orbital, so my answer there is 1. Now my ML is where I've got to find that pattern. So I've got 3 different orbitals right here. So that means the middle one is going to be 0. This is -1. This is +1. But remember, I'm always focused on that last electron that's placed in the orbital. So it's that one right there that I've circled, and that's a +1. So the answer here is +1. And then again, your MS is just, is it an up arrow or is it a down arrow? If it's an up arrow, remember it's a +1/2. If it's a down arrow, it's going to be -1/2. This pen is hard to get used to. So this one is an up arrow, meaning my answer here is +1/2. Okay, so that's the first one I'm going to do. And I'm going to try to add another slide here. Okay, so my second one that I'm going to do, I'm going to do a harder one. I think I'm going to move into the F block. So we're going to do samarium. So if you find your periodic table, I want you to find SM. So it's going to be, if you look on your laminated periodic table, it's in the orange row at the bottom in the lanthanide series. It's number 62. So instead of writing out the whole electron configuration here, I'm going to abbreviate it. So if I look at samarium and I look at where it would fall and what noble gas comes before it, it's actually the noble gas that comes before it is xenon. So after xenon, when I go to the next row, the next orbital that's filled is 6s, and 6s would be filled. Then what I have to do is go down, because before the d orbital gets filled, I've got to go down to that 4f orbital. But here's the issue with your periodic table. After you get through barium, which in 6s2, you need to look at the next element, which is La, number 57. That counts as the first one in the f orbital. Then you go down to 58, that would be 2, and then count over 3, 4, 5, 6. So samarium is actually 6 over. So if you don't catch that, what you're going to see is you're going to have a 5 here instead of a 6. And you're going to have, if you add these up, xenon is 54, that would be 6. 56 plus 6 is 62. So it does meet that 62 electrons. If not, if you added it wrong or you put the wrong number in that last orbital, it's not going to add up to the number of electrons. So again, at this point, I'm really focused on what's going on with that f orbital. So an f orbital has 7 orbitals in it. It's got 6 electrons. Remember, you have to put 1 in each one before you pair them up. So that's what that looks like. And I'm focused on that last electron that's been placed in there. So I've got to come up with, what is my N, what is my L, what is my ML, and what is my MS. So again, N is right there. It's what orbital or what level I'm in. So that is a 4. And then my L is what type of orbital. So again, S is equal to 0, P is equal to 1, D is equal to 2, and F is equal to 3. Well, I'm dealing with an F orbital, so that answer is going to be 3 this time. So on this one, on ML, I'm looking at what's going on with the different orbitals right here, where my arrows are. So I've got to find that pattern. So this is going to be 0 right here. This, again, would be -1, -2, and -3. So this would be +1, +2, and +3. Well, my electron is sitting in the +2 orbital. And then it is an up arrow, so it's +1/2. So that's the next, or that's samarium's quantum numbers. Now we're going to move on and we're going to do lead. So for lead, if I can find it, lead on the periodic table is number 82. So we're looking at PB, number 82 on the periodic table. So again, I'm going to look at the noble gas that comes before it, and it is xenon again. So it's going to be xenon. And then the next row, again, the 6s is going to be filled. And then again, before you do the 5D, you have to fill the 4f. So 4f is going to have 14. And then you come back up and you fill the 5D orbital with 10. Now you're at the green section of your periodic table and you're 2 over to lead. So that would be 6p2. So I'm really focused on what's going on with that p orbital, that last one right here, that has 2 electrons in it. And I'm specifically looking at that electron to determine what's going on here. So I've got to figure out what is my N, what is my L, what is my ML, and what is my MS. Okay, so N, again, level, it's in level 6 right there. So N is equal to 6. L, it's a p orbital. So again, S is equal to 0, P is equal to 1, D is equal to 2, and F is equal to 3. So my L, because I'm in a p orbital, is going to be 1. And then my ML is going to be, if the center is 0, again, that's -1, so that's +1. So this right here, your ML is going to be 0, because that's the orbital that electron is in. And again, it's an up arrow, so it's going to be +1/2. All right, I'm going to do one more. So the last one we're going to look at is americium. So americium is number 95 on the periodic table. It's all the way in the very bottom purple row. Its atomic mass is 243. Okay, so the noble gas that comes before this one may be a little bit tricky, but the noble gas that comes before it is actually radon. So radon is 86 electrons, and then I go to the next row, and that next row, the 7s is filled. And then I need to go down to the 5f orbital. But again, like the one example before, once I start counting, I've got to count actinium, number 89. I've got to count that as 1. Then I go down to the purple row and say 2, 3, 4, 5, 6, 7 over. So this would be 5s7 to get americium. Now, if you add it up, 86 plus 2 is 88, and then plus the 7 is the 95 that we're meeting. So just double check that you have all those electrons placed in an orbital somewhere. So again, to get my quantum numbers, I'm really focused on that 5f orbital. So they're made up of 7 orbitals. So again, I got to place 7 electrons. So there's going to be 1 electron in each one of these orbitals, but I'm really focused on that one right there. So my N is equal to 5. My L is equal to what type of orbital? It's an F. So again, S is equal to 0, P is equal to 1, D is equal to 2, and F would be equal to 3. So this is 3. And then my ML is going to be, find that pattern. This one would be your 0 because there's 3 orbitals on the left, 3 orbitals on the right. That means this guy is -1, -2, -3. This is +1, +2. That's +3. So I'm focused on the +3 orbital where that electron is located. And then the MS, I have another up arrow. There will be down arrows. These examples just happen to all be +1/2. So that's kind of it. That's how you kind of focus on how to do these different quantum numbers for the elements. If you have any more trouble, make sure you email me. Let me know. I can set up a Google Meet with some of you guys. Thanks.